So I'm recording this video in request of Aisha Jabri, grade 6, CA week 4, science. Let's start. So light interacts with matter in different ways. So whenever you have light and matter, you need to understand their behavior. Okay, there are two things mainly that you need to understand. That light gets absorbed and transmission. So these two things. Now what happens in absorption? What happens in transmission? So absorption is when objects, like for example a sponge, it will take in water, it gets heavy, right? And it just absorbs the water inside. Think of absorption in that way. Transmission is the passing of light through matter. So whenever you have light, it goes through the object. That's transmission. That's it. So transparent describes an object that transmits light and is see-through. The transparent describes an object that transmits light and is see-through. So for example, keep in mind that is a glass. Okay, a glass. Why can you see on the other side? First of all, it lets the light transmit and it is see-through. Opaque, on the other hand, is the opposite of that. Opaque object, it does not let any light pass through. It does not let any light transmit. So when light shines on opaque object, it just gets reflected. None of light passes through. So it just completely gets reflected, all of it. Reflection, we're going to study in the next page. Some objects allow some light to pass through and are therefore partially see-through. So they are translucent. Not all of the objects, not all of the light is passed through, and not all of the objects are reflected. So it's in the middle, right? Frosted glass, for instance. So keep in mind these three examples. Transparent glass. Opaque will be an object like a door. You have to open to see who's on the other side because it does not let light pass through. Translucent, like for example, there is frosted glass and you're trying to look for your brother, through the glass. Maybe he's playing outside. So what will happen? You'll look through the glass and you'll try to figure out, if your brother is playing outside or not, outside in the garden, sorry. So you cannot see directly if it is him, but you can figure it out. So you can see a reflection of them, like a figure, if it's like, if someone is playing outside or not. The law of reflection is bouncing back of a light ray. So what happens? There's something called an incident ray and reflected ray. Reflected ray is what reflection is based on. Light that is not absorbed or transmitted by matter is reflected. So it is not allowed to be absorbed and is transmitted. So the law of reflection states that ray reflects away from surface at a same angle r as the ray hits the surface I. So now they're talking about these two angles. There is an incident angle and there is a R angle. The law of reflection states that a ray reflects away from the surface at the same angle as it hits the surface. Understand these things, you just have to know these for basic knowledge because they're mostly used for mathematics, okay, for calculations and stuff. So in a mathematical expression, the law of reflection can be expressed as I equals to R. The angle is measured with respect to the normal. So this is the normal, which is made with the reflecting surface. The angle is measured with respect to normal, which is the line perpendicular to reflecting surface at point where the light ray meets the surface. So now here, this meets the surface, right? The light is hitting the surface, and then there is the object is reflecting a light, and to that object we're making the normal, and to that normal is what we are. The reflected ray will extend that line from the reflected ray to the normal, will make the R, and from the normal till the incident ray, you'll make the I. Okay, so these are how you'll figure out the angles. Again, you just have, it's a basic, it's just general knowledge. This is usually for math. So light rays that bounce off are very smooth surfaces such as a flat mirror and can produce an image. So light rays, for mirrors, they can be, and they are in a pattern. You can see that they're in a specific pattern. Now you can see this beetle as well. Why can we see two beetles? Like not completely two beetles, but we can see a reflection of it. Why? Because that surface is hitting light. And that light, the surface is hitting light of the image of the beetle. I hope you guys understand that. Which produces an image. Now the color of an object. Whenever you see an object, right? An object not... so first of all, there are three things that you need to keep in mind for this. There are white objects that absorb all the light. Remember rainbows? How the different colors are there? That is how your white light is made up of. For that, your white light, all of the colors get reflected. They get reflected back to us, back to our eyes. So we know that the object is white, like our walls are white. So if you look at the walls and you can see that it's white, it means all the light, the white light that is hitting it, all the different colors of the rainbow are coming back to our eye. So we know it's a white light. For colored objects, such as the yellow, you'll understand the concept better now. So the yellow, it reflects the yellow light, and that's how we know that the object is yellow. Then there is the black object. Black object absorbs all the light. So when it absorbs all the light, so it means that we cannot see anything. It has no color. Do you guys understand? These are the three categories. Then there is law of refraction. What is law of refraction? Refraction means that some of the light, it bends. Okay? So the light that is transmitted through matter can bend. Refraction is the bending of light ray when they pass from one medium to another. So what is the medium? It can be air, water, or any solid. So refraction happens because speed of light is different in different mediums. So refraction, why does it occur? Because in the air it will be a different speed, and water it's going to be a different speed. As you can see, the light where it first starts, initiates, is your incident, okay? Now here, the light is faster in the air than in water. So when light passes from air into water, the light will bend towards the normal. The normal we've already made it, okay? And it bends towards the normal. So it means that the refraction angle, is smaller than the incident angle, okay? Now, is the greater than the angle of refraction. The thing is, now think of it as opposite. It's now going from a slower medium, which is the water, and it's going into a faster medium. So it bends. Sorry, one second. So it bends away from the normal, right? So it bends away from the, now here, the light that it's where the first starting from is called the incident, okay? And then it's the, what is that? The refracted ray is the one that leaves, that goes to the second medium. So for example, in this one, in the air, that was the first medium, it's called the incident ray, then the second medium is refracted. The same thing, then water is the incident because that's where the light started, then it's called refracted. This is all based on refraction, based on speed of light of different mediums where the light is traveling, okay? And then we have sound and matter. So sound and matter, so this just concept is just basically telling you that there are three types of matters: solid, liquid, and gas. The speed travels the fastest in solids. Why? Because the particles are closer together. Now this concept is also something that you guys have studied in your previous grades, in younger grades, because the particles are very tightly bound with each other. The light can pass through it easily, sound can pass through easily. Sound travels by making the particles in the matter vibrate. So it vibrates, and because the particles are together, they can vibrate they can faster. So the particle solids are closer together than in those in liquid and gases. As a result, sound travels faster. Therefore, the speed of sound solid is greater than the speed of sound in liquids. And then the same thing, the speed of liquids is going to be faster than in gas. So just that. It's just remember particles and sound. The closer the particles are, the faster the sound is going to travel. Now here, echo and thunder. Now what is sound? Usually it fades out whenever there's a source, right? So for example, if your teacher is talking to you, the teacher's sound will be, you will hear it more greater than someone standing outside, right? So it's the source is your teacher, and the sound, it spreads out, so it becomes weaker. So sounds can bounce back from surfaces. Echo is created by sound that bounces off a surface. Bats and dolphins evolved a complex technique to navigate. So now we're talking about echo and echolocation. So sounds can also bounce back from surfaces, like we learned about reflection in light. Now what is echo? Echo is created by sounds that bounce off a surface, right? So what are they? Bats and dolphins. And they evolve a complex technique to navigate and find food in the dark. So two things. They find the way and they find food in the dark. And this technique is called echolocation. So whenever they want to find food or they don't know where to go, so if they have a large stone or something, they'll send out their waves, and then they will see where is the, if they will see there is food, right? So they will know that this is the echo. The bounce back of the sound is that it's food for them, right? So they'll understand those. So who does that? Bats and dolphins. So you know that bats, they live in the dark. So echolocation is something really great for them. By listening to echo, they're able to locate food source. Thunder is another great example of sound traveling. Sound. So what happens in thunder? It's a natural phenomenon in which involves sound energy. Thunder occurs following a lightning strike. So what happens is that there is a lightning. What happens is that it's air, right? It heats up the air 30,000 degrees Celsius in a millisecond. This sudden heating actually makes the air expand. And this moves the particles so violent that you hear the thunder, right? So this is what you do. You see the lightning faster first, then the sound. If anyone has experienced lightning, I don't know if everyone has, but you can see that you will see the light and then the sound. Why? Because light travels faster. So it's faster 300,000 kilometers per second than the sound. So this is the explanation of this. It's just a 10 minutes explanation. I hope you guys understand it, and I speak really fast. So I hope it's a quick revision. Take care of yourselves. And if any questions, ask in the comment section, and you'll have my number if you ever want to contact me for any questions.